Guys, so we're gonna have to switch to online lectures, which is completely weird for you and for me. So let's just try to get through this, all right? So our goal for today is to go over rational functions. If you were here for the last class, right before we got kicked, we went over rational functions a little bit. So let's just review what they are. Rational functions are functions that have x's in the numerator and denominator. So you'll see it written in textbooks like this, where h of x equals f of x over g of x. Okay. This just means that we have some function that equals some polynomial, right? So some plus or minuses of x's divided by some other polynomial. So here are two examples, right? We have x squared minus 1 divided by x plus 1. So in this example, this numerator right here, we would refer to him as f of x, and this denominator right here, we would refer to him as g of x, right? Here's another example of a rational function, x cubed plus 1 divided by x. If you want to think about which one's the f and which one's the g, well, x, because it's in the denominator by itself, this guy would be g of x. Okay, and our f of x here would be x cubed plus 1. So this polynomial on top would be referred to as f of x. The other guy would be referred to as g of x. And it's probably going to be written as something like this, like, h of x equals this whole thing. Okay, so rational functions are kind of weird because a lot of odd things happen to them, or rather with them. So here are some stuff that happen. 3 things. And by the way, I'm going to try to keep these lectures short and precise as much as I can, because I know no one wants to sit at the computer for an hour and a half listening to me talk. Okay. Functions. All right, so 3 things can occur with rational functions. So the first thing that could happen is that in our picture or our graph of our function, holes can pop up. So places where the function is undefined in the graph. Okay. I'm just going to give you a quick overview of everything, and then we'll break it apart in later videos. Then another thing that could happen are vertical asymptotes. So vertical asymptotes it's an invisible line which our graph cannot cross, and this invisible line goes straight up and down, and that's why we call it vertical, right? So for example, if we have something looking like this, right? This is our x-axis, this is our y-axis, and here's our curve. Whoop. Sorry guys, I'm getting used to this too, so help me out here, okay? So you see how our graph goes up towards this x value? When it gets closer to this x value, my y value shoot up. And if I come from the right hand side, as I get to this x value, my values start going down. So let's just pretend that this is x equals minus 4. Okay, let's just pretend. So you see how our graph never touches anything at x equals minus 4. This means that we have a vertical asymptote at x equals minus 4. It's an invisible vertical line such that our graph does not touch. Okay, and We got one more. We got a horizontal asymptote. Horizontal asymptote. And really, these are analogous to the vertical asymptote, except they're invisible horizontal lines that our graph cannot cross. Okay, and the thing about horizontal asymptotes is that when we talk about our graph not crossing it, we really mean for very, very large numbers of x's or very, very small numbers of x's. And you'll see what I mean. We're going to go over some graphs that will depict this, okay? But right now I'm just giving you a general overview. So a horizontal asymptote, just to make this complete, will be something maybe like this. If you hear weird noises, it's my cat running around going crazy and crying, as you can hear maybe, because she wants me to play with her, and she's only 5 months old, so we're all struggling here. Okay, so well, maybe I should have made that dotted just to make it easier. So here we have a horizontal asymptote. So our graph gets very, very, very close to this horizontal asymptote, but notice how our graph never touches it. Okay, so a horizontal asymptote is an invisible horizontal line that our graph does not cross. Okay, and let's just pretend this was at y equals 1. Okay, so now we're going to go over identifying. How do we know when our rational function has a hole, has a vertical asymptote, or has a horizontal asymptote? And we're going to do that in the next video, okay?